For 2015, what I talked a lot about was the possibility that equity crowdfunding was going to turn out to be an enormous force inside of this whole space. I gave a very ambitious, very aggressive talk. It was basically just equity crowdfunding was going to change everything. Get ready, here it comes. And sure enough, we've got $160 million equivalent in an equity crowdfunding type platform called the DAO, which was started right here in the UK by the Slot Locus. So with that kind of emboldening my sense that I want to make some predictions, I'm going to try and talk about what I think the next year will hold in the entire crypto space as a little bit of a kind of state of the union. For those of you who don't know me, I'm currently with Consensus Systems as basically a strategic architect, which means I spend the majority of my time figuring out how to explain these technologies to diverse audiences in a way that will allow them to actually make decisions. And a lot of that is getting people away from the idea that you have to understand what mining is or exactly what a gas limit is before you can go out there and actually develop some ideas about how to use this stuff. People seem to love the low-level explanation. They always get pulled down into the low-level explanation. But actually, we don't do that for the majority of our technology. If you think of something like the LAMP stack, everybody uses the LAMP stack or the mean stack. Nobody ever really worries about SQL query optimization theory. And that's kind of where we are with the explanations of these things, which are very oriented around mining or even proof of stake. Everybody wants to get to this super low-level understanding of what's happening in a way that they don't for the technologies that they're already used to. They don't really care. Prior to this, I was the release coordinator for Ethereum. So I basically project managed the launch of the software, and that involved an awful lot of time worrying about those kind of low-level details, but not nearly as much time as the programmer spent worrying about them. So with that as preface, I want to basically talk a little about the singularity, and then I want to talk a little about why I don't think it's happening. Could you raise your hands if you've heard of the singularity? Okay, about half of you. So the singularity is an American concept that took root in Silicon Valley maybe 10 years ago. And the singularity basically suggests that you're going to get to artificial intelligence. The first artificial intelligence will be used to design the next artificial intelligence, and pretty soon you'll have super intelligent artificial general intelligences which can do everything that a human can do but better, and which exist delocalized across the internet in a way which is very reminiscent of the blockchain. And at that point, humans will basically be obsolete, and we should make way for our robot overlords. Now, for me, the singularity was a very unreal concept until about 6 months ago, when suddenly London caught up with the singularity. There were a couple of pieces of big news. The deep learning stuff, where you kept seeing these weird dog lizards come out of this. You see this Google's DeepMind thing, all these weird dog lizards? So that stuff, the stuff where you took a painting and then a photograph and then redid the painting in the style of the photograph. So redid the photograph in the style of the painting. That stuff was amazing. And then the victory of computers over the Go game. This very old Chinese Go game, which has been one of the high watermarks for artificial intelligence. Oh my god, if we ever crack Go, we'll almost be there. And most of the people I know that were close watchers of AI found that that had happened 10 to 15 years before they really predicted it had happened. It was a generational jump within a few years. So that confluence of forces put the singularity back on the table for me in a very real way. And I had to sit down and really have a think about whether or not I thought the singularity was happening, whether or not I thought it was important. And I sat down and had a think, and I came to the conclusion that I don't think I give a monkeys. And let me explain why. I think that artificial intelligence is probably coming. I think it will be niche intelligence long before it's general intelligence. But niche intelligence, I mean things like it knows how to pack boxes, or it knows how to identify molecules using a mass spectrometer. General intelligence is you can give it an entirely new problem domain and it'll figure out a way forward. Okay, so let's try and teach you ancient Greek. You don't know any ancient Greek, figure out how to learn it. Machines that can figure out how to learn are basically the core of general intelligence. My belief, and I'm waiting to be proved wrong on this, but I think I'll give it a try, is that artificial general intelligence past about an IQ of 150 to 180 will turn out to be just as bonkers as people are at those kind of IQs. We all know very intelligent people have a terrible tendency to prove to themselves that something is true, which is obviously not true, but they're so skillful at manipulating the evidence and marshalling arguments that they convince themselves and then they convince other people, and pretty soon you get a UFO cult, or ancient aliens, or neoconservatives. So this sort of model that the more intelligent people are, the greater the tendency is for them to self-convince themselves of false positives, is why I don't think we're going to see artificial superintelligence. I think you might get attempts at artificial superintelligence, and I think that their tendency to be just completely insane will greatly limit their utility in the real world. We might wind up with a few special instances where people are attempting this kind of stuff, but I think in general we're going to discover that AI is a poor substitute for systems that evolved over 1 billion years to trade off very skillfully the balance point between intelligence and craziness. However, what you could get is very, very, very fast intelligence that is relatively limited. And the prospect that you could wind up with extremely intelligent machines that do your job 100,000 times faster than you do and much cheaper is very realistic, particularly for people that are pushing paper for a living. So the reason I wanted to frame that is a lot of times we talk about this blockchain stuff as if it is going to single-handedly be the end of civilization. And actually, it's only one of about 7 or 10 horsemen of the apocalypse that are all marching over the horizon really, really, really quickly and are tearing apart the very fabric of our expectations about reality far faster than even young people could cope. For example, virtual reality gear was something that you would see maybe once or twice a year. Now you see it basically every time you go to a conference, and if there's any sufficiently large gathering of nerds, somebody has VR kit in their backpack, and they'll get it out if you even mention it. So by the time all this gear is launched from Facebook and from Samsung and from Sony and from everybody else that's on the market, you can buy it at the launch of games, it's being reviewed in the magazines, and you can buy it in Dixon's and all the rest of that stuff. At that point, VR is going to be something that you'll see 4 or 5 times a day. There'll be people sitting wearing VR headsets on the bus on the way to work. There'll be people sitting down in corners of McDonald's plugging into the Matrix to see exactly what's happening. Right? You'll go home and your kids won't remember your name. And you know, I talk about Christmas 2016 as being the last Christmas anybody will see their children, because they're all going to get VR gear for Christmas, and then the next Christmas you're not going to be able to get them back out of the Matrix 20. And if you think it's hard taking them off Facebook, imagine what it's going to be like pulling them backward out of Lord of the Rings. Excuse me, we're about to get rid of the One Ring. You can't take me out. So, the artificial intelligence, the virtual reality, the drones, the robots, you know, what else is moving in this direction? The nanotech, the biotech, the life extension stuff, which gets into the biology, which I'm not going to touch on. Just know it's there. All of these things are basically pushing us outside of what has been the traditional understanding of technology, which was technology was stuff that you could see and feel and touch. It was machines, it was gadgets. And what's happening is that we're beginning to break out of the model where technology was gadgets and into this new world in which technology basically constitutes an environment. And that shift from gadget-centric to environmental, we've talked about this in terms of things like Internet of Things, we've talked about it in terms of things like ambient computing, sensor networks. It's bounced around for a long time. But the bottom line is that we're moving into a world in which the kind of techno world is wrapped around us continuously at all times, and it's increasingly a single integrated mass. So you look at something on Amazon, you put it into your shopping cart, you decide you're not going to buy it quite yet. The next time you go to Facebook, there are 38 copies of it looking at you. Don't remember looking at that there, right? Even worse, you buy the thing and there's still 38 copies of it on Facebook following you around. They must be wasting $1 trillion a year advertising products that people have already just bought. And unless there's some sneaky reason to do it, it's just an example of planning the software, of planning the paradigm. So these environmental technologies are already wrapped around us. But how much more powerful does that become when we begin to get artificial intelligence, blockchains, and AI smoothly operating as a seamless service? You have your goggles, and you look into a virtual world, and the stuff in the virtual world is directly connected to a blockchain. So when you sell something to somebody or give something to somebody, it really is property that has been transferred to them. And not even the NSA can reverse the transaction. The thing is sold. There are no rules by which the game your pockets and unpick them. The stuff is gone. If that is then, integrated into your mobile phones and your thermostats and your everything else, your house lights flash with your castles under attack in virtual reality, and you go over there and sure enough, you check your blockchain inspector and half of your stuff is already gone. Now you have a problem, you phone up your friends, they all leave the party they're at to get online so that they can go chase their orcs that have stolen all your virtual property in your imaginary game. This kind of sounds like comedy, but I guarantee you that you're going to be reading the scary news about this kind of stuff in the red top newspapers within 6 months of a year. Certainly next year or the year afterwards. I think the narrative that the blockchain is a singular breakthrough is going to be replaced by a much more general understanding that the entire world is changing really, really quickly in some totally unexpected ways. Smart contracts, I think, are going to be a huge part of that transformation process. Could I have a show of hands for everybody that's comfortable with a smart contract? Okay, so I'm going to spend a wee bit of time explaining smart contracts. We'll talk for too long, but try and get me some of the detail in place. So, when I take a little detour and teach you all how to explain blockchains to people who don't understand blockchains, that'd be useful. If you can remember how this explanation works, it'll make everything that you're doing a ton easier. So, start in the 1970s, and we'll get to smart contracts, by the way, but this is the easiest way to get to smart contracts. Start in the 1970s, one computer per organization. The computer is a big, fragile machine, big, clean room, and people wear white coats and funny little hairnets because if a stray hair gets into the tape drives are an inch thick and like 600 meters long, and if the tape gets tangled up in hair, it can rip your customer data to pieces. So the machines are treated with extraordinary care because they're incredibly fragile, and that applies both to the hardware and the software. There are stories about machines that crashed, and it would take 3 or 4 days for a team to, they would fly out, they'd sit with the machine, they'd spend 3 or 4 days reconstructing what happened line by line by line by line before they could even get the mainframe to reboot again. These things were very, very delicate. They get the same kind of care that we would give, delicate scientific equipment, particle accelerators. These things were, very delicate. So there's a kind of prehistory where these machines were programmed by hand, and if you wanted to do a query that matched data on 2 tapes to each other, you'd have to run the tapes manually. Okay, advance 11 inches, read record. Advance 16 inches, read record. Are these 2 records the same? Yes or no? If no, advance 11 inches, get next record, check record. And you'd write these little programs in COBOL that would process the data. And it was incredibly expensive and difficult to get anything done with computers, but it was still thousands of times easier and cheaper than doing it on paper. This is the prehistory. 1970-something, a guy called Codd at IBM, comes up with a thing called the relational model, SQL. And SQL takes these tape drives and that entire model of the database and its tables and all the rest of that stuff and says, underlying this, there is a multi-dimensional algebra. Each table is one axis of an enormous cube, 12-table database, 12-dimensional hypercube. Inside of that 12-dimensional hypercube, we can then close off dimensions one at a time until we're left with 2 dimensions using a simple algebra, and that 2-dimensional locus that we have defined is the table that will be returned to us as a result of our query. So you start with 11 to 12 dimensions, you say where name equals Smith takes away dimension, where city equals London takes away dimension, where purchase order equals customer ID takes away dimension, and you take away the dimensions and you collapse from this 12-dimensional space with infinite data down to 3 dimensions, 2 dimensions, give me those 2 dimensions as a table, and this is essentially what SQL does. So it tamed this enormously complex, set of software and hardware interactions that you had to wade through to get simple things done with your data into an algebra that once you got over the hump of realizing that you were basically cancelling off dimensions until you got down to the data you were looking for, was something that ordinary programmers could do pretty easily. And the result of that is 20 years later, by the 1990s, you had a handful of really big software companies like Oracle and Sybase that all had their own SQL implementations. There were hundreds of thousands, if not millions of people in the world that could make SQL do more or less anything they wanted it to do, and that generation of machinery had been completely taken. it's worth thinking about that because, how domestic and mundane is the SQL database today? Does anybody even think about the multi-dimensional algebra inside of a thing? Or is it all completely invisible and lost and you just think, why is my join returning enormous amounts of stuff? Right? Your join is returning enormous amounts of stuff because it's iterating over a 9-dimensional space. And it turns out that the volume of 9-dimensional spaces is extremely large. This might be a little bit. So, 70s model, hardware and software are in sync. By the mid-1980s, we get the IBM PC. The IBM PC gives us one computer per person, or one computer per desk, rather than one computer per institution. And one computer per desk, the personal computer revolution, again, completely lost the history. Sure, under the age of about 45, you have no real awareness that one computer per person is a radical concept. You just take one computer per person as completely for granted. If you're under about 35, you think of that one computer per person as being a laptop. The idea that the only computer that person could own would be a desktop and you couldn't use your computer except at home seems completely mysterious. Right? Think back to the age before Wi-Fi. Before Wi-Fi. It's only about 15 years. When you had to plug the computers in before there was any network. It's only about 15 years. So, along comes this PC revolution, 1986, 1984, one computer per person. The computers per person model then gets into this question of, well, this isn't very useful because the data I want is on your computer or your computer or your computer. So to return that data to me where I want to use it, typically, if you're in the same office, I go over with a floppy disk, you put the data on the floppy disk, I take my copy to my computer, and then I work on it. But then your computer and my computer are out of sync because your copy of the data doesn't have the update on it. So I then have to give it back across to you and synchronize it with you, but in the meantime, Bob has come and taken a copy and is working on it on his computer. And none of the software in those days was capable of taking 4 or 5 copies of the same file and merging all the changes from all those copies into a single unified status. Even today, that's still a hard problem. Git, for example, is all about that. So that problem continues to be a really core problem for about 10 years, from about 1990 to about 2000. The synchronization problem only gets worse because we do eventually network the computers together, first with Ethernet, local area networks, then with the internet. The web then provides a super user-friendly experience for working on the internet. Remember, the internet's around for a good decade before the web comes in. FTP and PostScript files, so you can look at people's documents. Did those words even still have meaning? FTP and PostScript files?
Yeah.
Right? File transfer protocols, you connect the machine and it would show you a directory listing like the one you get on your machine. And then you would download a file in an archaic language called PostScript, which was a series of equations which would describe letter shapes or curves that would make an image, and it would all be rendered either at your screen resolution or for a laser printer.
I'm still using that.
PostScript.
I'm still using
You're still using PostScript. Yeah. I mean, it's inside of, for example, PDF is very strongly inspired by PostScript, and PDF is the standard renderer inside of Atlas. All of these technologies have prehistories. So we don't solve the synchronization problem with many copies of the same file going around until we get to the kind of golden age of client server. The golden age of client server comes around 2 or 3 different times. The golden age recurs. One giant computer maintained by somebody else as a service. You never have to worry about it. Many users connecting to the giant computer so that you can run all your jobs and so on, and the giant computer keeps everything synchronized. It used to be the Oracle mainframe that people would connect with green screens, then it became Google Docs and all the other equivalent services. Even things like Facebook were essentially client-server terminal models, where you have a single perfect computer that somebody else is responsible for maintaining, and you connect to it to do your computer. That paradigm always results in users getting screwed. Right? Because so much power is concentrated in the center by the people that own those technologies that it's extremely difficult for the users with their little green screens to get any real leverage on the system. Facebook is very large, your laptop and your web browser are very small. So, to reprise, 1970s, big databases. 1990s, we network the computers together. Initially, we do all of our work by message passing, but message passing results in a synchronization problem. We then solve the synchronization problem in the same way that the synchronization problem has always been solved. Client-server architecture, which is the golden age of Google, Facebook, and all the rest of these things. The client-server paradigm never dies, it is simply the centralization of power. But you also get centralization of services. Somebody is responsible for making sure your data survives. Along then comes the great revolution in the form of Bitcoin. Because Bitcoin comes along at the real apex of the client-server paradigm for doing computing and says, actually we've got something new. Right? We're no longer swinging between the network and the database. We're no longer swinging between peer-to-peer and client-server. We can have something which has the static shared picture of reality that you get from the best client-server systems. So not like anarchy of message passing, but something that does not create a powerful center which will then extract $100,000 a year as a use fee from your company. And that squaring of the circle is really something fundamentally new at an academic computer science level. Nobody had ever managed to figure out how to get a computer system to behave in such a way that you got the best of client server and you got the best of this peer-to-peer stuff as a synchronized whole. And the Bitcoin mining process, which is at the heart of that, is an enormously ugly hack. Right? Mining is the worst way of doing this stuff apart from all of the others. It has a lot in common with democracy. It's horrendously expensive, it's messy, it's complicated. People continually attempt to hijack it and you have to trust the system to sort itself out again. But nonetheless, it continues to provide an approximation of good governance to the point where you can put many, 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 many billions of dollars into these systems and they hold together. So this establishes a new paradigm for how computers can work together, and that new paradigm initially is used to build, on one hand, what sounds very impressive, a central bank of the internet, and on the other hand, something which is incredibly mundane, which is addition and subtraction. And these are the only two operations that Bitcoin really supports. There isn't even a multiplier. So we go to all of this work to generate this enormously complicated peer-to-peer architecture, the blockchain with all its synchronization and all the rest of that, but all you get out of Bitcoin is addition and subtraction. Ethereum comes along, you take this addition and subtraction model, you pull a programming language layer directly into the blockchain. You have to rebuild the blockchain on new technology to do that, unfortunately. But once you've done that, what you get is programmability in a paradigm which is neither anarchic message passing nor centralized monolithic client server. And that paradigm, I predict, is going to turn out to be the dominant computing paradigm of the next 20 years, in the same way that the database was the dominant paradigm of the 1970s and 1980s, and the network was the dominant paradigm of the 1990s and the 2010s. The teens and the decade following the teens are going to be all about this paradigm of computing, where everything is connected to everything else and is continually synchronized in discrete units of time. The discrete units of time, by the way, are not going to go away. There's a minimum block time which is necessary because of the speed of light. To be able to keep everything synchronized, you have to have the messages go around the world basically twice, and around the world basically twice takes something like 1.4 seconds. So in all probability, you're going to wind up with a minimum block time of about 2 seconds, might be more like 3, could be as long as 5. Ethereum is currently running at 15. But the block is there because the speed of light is actually relatively slow compared to how quickly your computer is able to operate, because your computer operates by racing the light backwards and forwards over 0.6 of a centimeter surface, 6 millimeters of racing. And as the light races backwards and forwards over your processor that's only 6 millimeters wide, it can cover an enormous amount of computation compared to having to go 5,000 miles to LA and back. So the quantization of time into these blocks is a necessary step for fighting against the speed of light. And as a result, I think the block is going to stay as an institution. And this is going to become even more pressing when we start doing things like wanting to build computer systems that manage resources which are on the moon or space stations or Mars, where the speed of light delay becomes even longer and even more complicated, and thinking has to be done about how to manage block synchronization. Now, that's a very long explanation of what the blockchain is. But if you pull out the salient points, 1970s are databases, 1990s are networks, we unify the network and the database so that you don't get the anarchy of message passing or the centralization of power from client server, and then we make it programmable by putting programming language into you're up to date in 2 sentences, and you can drill down into that explanation as far as anybody needs you to be able to get a full set of facts from it if you want. Now, I'm going to take a moment to fiddle with technology. Could you restart that camera?
It's still recording.
Yeah, just stop it and restart it.
All right.